Welcome to our YouTube channel, students. So that's the question. That's the question of vector here. Okay, so now we are going to start with vectors on one side and permutation and combination on the other side, bachcho. So that's the question of a vector. See, it's a very simple question if we can solve it. I mean, if the idea hit our mind, okay, strike our mind. See, I got this question as a doubt and I found it to be a totally different type of question. So that's why I decided to start the vectors with this question here. So let's start. See, the question is, we have to just show it. We have to show that this vector equation represents a planar curve. Now what does that mean? A planar curve means a curve that lie on plane, whatever plane, whichever plane, doesn't matter. So it represents a planar curve. That's the question. Acha, I think we all understand that any equation of curve in vector form, there the variable is vector r, and what does it represent? Vector r actually represents the position vector of any variable point. So position vector of any variable point on that curve, whose equation we have written in terms of vector r, bachcho. Okay, so vector r represents position vector of any point on the curve whose equation we have written. For example, we all know that vector form of line is, if I just take example, I cap plus k cap plus some scalar times parameter, where p is a parameter, I cap minus j cap plus k cap. Now that's the vector equation of a line. Which line? That passes through this point. What is it? This is the position vector of a fixed point and whose direction is this. So that's the direction vector. Okay, so that's the line. Now here in this case, what does vector r represent? So if that's the line here which is passing through the point A, let's say this is A, whose position vector is I cap plus k cap and whose direction is along I cap minus j cap plus k cap. How many points do we have? We have infinite points on this line. So any variable point P, its position vector is vector r. Okay, so at times a student gets confused with this vector r. While using it, they have that feel that vector r is the position, is the vector that lie on that curve. Of course not, until unless origin satisfy that curve, whether that curve is a curve or it's a surface like plane or a sphere, whatever it is, whosoever you have written or you have mentioned the vector equation. Okay, if origin satisfy that equation of the curve of the surface, then only vector r will lie on that curve, on that surface. Otherwise, be very clear about it, bachcho, that vector r is the position vector of any variable point on that curve. So it is the position vector of any point on that curve or on that surface, whatever the case be. Okay, so let's come back. So now vector r is the position vector of any variable point on whosoever equation we have written. So I will say, okay, let's start. So I will say, okay, let vector r be, we know in 3 dimension we assume a point, a variable point as x comma y comma z. So in vector form, if I have to write its position vector, so in vector form I will write its position vector as xi cap plus yj cap plus zk cap. Isn't that? Now if this point, the point whose position vector is this, satisfy this equation, so just compare it. Okay, so since I cap, j cap and k cap are independent vectors, so if these two vectors, their linear combination are equal, that is possible only and only when their scalar coefficients are equal, the corresponding scalar coefficients are equal. So what will we do? We will do here, we will say, okay, so here on comparison you can say x is t. What is y? Y is 1 minus t by t, so it's y is 1 minus t by t. And how much is that? When you compare it, the coefficient of k, the scalar coefficient of k cap, z is 1 plus t square by t, bachcho. So it's 1 plus t square by t. Okay, now say, of course, what is the parameter here? Parameter is t. We have to eliminate t if we can. So see what I did, I just observed. So it's 1 by t minus 1 and z is 1 by t plus t. So you have t here, you have t here, you have 1 by t here, you have 1 by t here. So I just wrote x minus y minus z. That will help us in getting rid of t here. So what do we get? So we get this is equal to t minus 1 by t plus 1 minus 1 by t minus t, and that's it. That's what I said. So wait, x plus y. Okay, just a minute, bacho. X plus y, right? Minus z. Okay, so what do we get? So it's minus 1 here. So therefore the equation is in terms of x, y, z, x plus y minus z plus 1 equal to 0. Now whose equation is it? So in terms of x, y, z, this is the equation of a plane. Hence this vector equation represents a planar curve. So it's a plane itself. So that's a plane itself, the entire plane. So though it's a surface, it is a plane. Okay, so that was the equation here. So as I said, it had a different format, like parametric form of thing when we comparing it and then get eliminating t here. So that's why I prefer to start our vector with this question, bachcho.